Okay, hopefully the camera will come into focus, but what we're doing is sketching a graph that represents this rational function. And I'm not sure the camera is focused even now. Okay, here's the function. Now, it's a rational function. So what you do, find the y-intercept. Find 0 is the numerator. Find 0 is the denominator. I'm going to say find the long run function. If you just do the long run behavior the way Open Math has told you to do it, that's fine. But I think many of you understand the power function well enough that you can actually find the long run function. And in this case, you're going to end up doing that anyway. Okay, so that's 4 things you always do. And do it as coherently as you can. Write it out logically, write it out completely to reinforce what you're doing so you'll be able to do it when you need to do it on a test. Now, I will say that I'll have but we're going to talk about the midterm exam as soon as we get done with this rational function. That'll be in the testing center on Thursday. I'll say more about that after we get through this. But the reason I mention that now is I'm going to have a problem on a rational function on the test. That way, if you know how to do it, you get credit for it. Okay. If you don't know how to do it, I won't comment. Okay. So you'll either have, there are 10 questions on the test, and one of them is a rational function. If you don't do it or don't do well enough on it to help your grade, then I throw it out there, only 9 questions. I'll average it based on the 9. Okay. So there's no harm in trying to do it. But you know, time factors and so forth, you make those decisions. It'll be an optional question. Okay, so what do we do? Find the y-intercept. I keep telling you, write out my words. Okay, keep yourself guided in what you're doing because of what I see here. Is, you know, most people got a good start. Most people have a pretty good idea what to do. But it wasn't as good as what you apparently did on the homework in most cases. Okay. Some cases it was, but and I think if in doing the homework you had written this stuff out coherently with the logic, you would have been better focused and better able to do it. Now, what I saw, it isn't bad. It's, you know, you're within, everybody seems to be within striking distance of being able to do this well. Okay. And some people are already there. You know, the test wasn't horrible, the quiz wasn't horrible, but these things could have been better. Okay. So I'll point them out as we go. Because again, I think if you just focus a little more, you'll have that. And this is one of the more difficult things, of course. Okay. This is fairly complex, it's fairly challenging. Okay, well, find the y-intercept. if you write out the y-intercept occurs when x equals 0, you don't have to write a whole bunch of words. Just y-intercept when x equals 0, or even y-intercept colon x equals 0. Some indication that you know what a y-intercept is and what x equals 0 means. On, you know, in terms of graph, of course, you know what x equals 0 means. So I'm not going to write out all the details. We're plugging in all the zeros. We're going to have a -2 out of this one because the x will be 0. These will be 0. You'll have a 7. These will be 0. You'll have a 6. So it's -2 times 7 is 6. And that's going to be -7/3. I mean, -14/6 is going to reduce to -7/3. Okay, so if you have a graph sitting over here, waiting for you to put stuff on, not a bad idea. Go ahead and mark this point. And I like the idea of using the line y equals -7/3 to indicate the coordinate here. So you're not labeling coordinates next to the axis where things often get busy and you got to draw lines through them and so forth. Okay, so kind of like this. Not necessarily required unless I ask you to draw the lines explicitly. But you're going to have some indication that you know that. You could, of course, you can label that point 0, -7/3, and you're probably going to label it right where the graph was through your label. That's about the perversity of reality is going to make that happen. Okay. So anyhow, second, that's easy. Yeah, we're indicate numerator equals 0. Doesn't take long to write that. And then you write numerator equals 0. Simple logic. Then you use the zero property of multiplication. Last time I wrote out by the zero property of multiplication, etc. And I really urge you to do that. I'm not going to take the time to do it today. I'll just put a few dots there. I really want to see this, x minus 2 equals 0, or x squared plus 3x plus 7 equals 0. And then you're going to get x equals 2. I'll put a few dots. Dots mean there's a step that should be filled in, but the step is add 2 to both sides. And everybody can do that in their head. I can accept that. Or you recognize that this is a quadratic equation. Okay. Now, half the people seem not to recognize a quadratic equation when they see one. Quadratic equations are really easy to solve. Everybody knows a quadratic formula. You just have to recognize it when you see it, okay? So start recognizing quadratic equations. Okay. There's this thing that we used to see a lot of. I don't know if you see it anymore. I've seen it recently, but start seeing motorcycles. Okay. A lot of people get killed in motorcycles because people don't see them. Well, start seeing quadratic equations. Okay. Because if you see that, it gets very easy. So you end up with -3 plus or minus the square root of -19 over 2. That's not real. Okay. Square root of -19 is not a real number. You want to see how it's written out, look at, you know, I worked through one almost the same as this one in the support course. I had a few more details, okay? And I showed what to do with that, but I'm not even sure I'm going to test you over it. So recommend that you understand it because it's kind of important, but not necessarily immediately important in this course, okay, for your grade, unless it is. in this context, it won't be. All you got to do is say not real. I can't even read that, but it says x squared plus 3x plus 7 is irreducible. You can't factor it over real numbers. Doesn't have any zeros. Any real zeros. Okay, so now we know that at x equals 2, we have an x-intercept. So this goes along kind of nicely. But what about 2 as the denominator? Another reason for writing out what you're doing, some identifying like numerator equals 0, denominator equals 0, y-intercept, and x equals 0. If you get further along in the problem and forget what everything means, you've done it by habit, it's there, but now you got to go find it. And it's scattered all over the page and not with headings. Well, if it's scattered all over the page, fine, if each little area tells you what's going on. Okay. So you got this somewhere in your page with the heading numerator equals 0, you know immediately what you're seeing, and you know immediately what to do with it. Denominator equals 0, we'll work that out in a second. You immediately know what you're doing. Yeah, I mean, you immediately know what you're seeing when you see that, and you don't have to say, what was I doing there? Why was I doing that? Write things out. You can factor this. And you could get it. Alternatively, you can use the quadratic formula. That I'm not going to write out the details of the quadratic formula every time. Just for time and because I know you already know how to do it. Okay, you don't need to see me write it out. But this indicates you use a quadratic formula. So you got two alternatives. A lot of times you can't factor it. Matter of fact, in the real world, most of the time you can't factor it. And you're going to have to use a quadratic formula. Okay. So that's step 3. We know where the denominator is 0, right? And maybe we even write ourselves a note. Here the numerator is 0 for x equals 2. Denominator 0 for x equals -2 or x equals -3. Okay, so now what do we know? We know we have two vertical asymptotes because the denominator is 0 for these numbers and the numerator isn't. Now in the support course, we had a case where I had a +2 here and the numerator and denominator were both 0 at -2. Okay. So that got a little more complicated. In this case, we know that we have zeros, but zeros are the denominator. We know we have vertical asymptotes at those points. I'm going to use a light solid line. These vertical asymptotes. Label them x equals -3 and x equals -2. I did say to somebody, who wrote down a -3 here and a -2, write x equals. And if it's a horizontal line, write y equals. So you really don't ever have to stumble over what the meaning of a x equals 5 or y equals 7 ifs, because it's real easy to be confused on that. In the habit of writing these out, which takes only seconds, and probably only going to take 10 minutes out of your life in the whole course, it's going to put more into your life than it takes out of. Okay? It's going to make you real secure with the meanings of these lines. Now, there it is. These are vertical asymptotes. Now we want to figure the long run. R of x is a degree 3 polynomial divided by a degree 2 polynomial. A little, and you wouldn't have to necessarily write out all this, but so the degree of the long run function is 1. Why? Because this is basically an x cubed function, this is basically an x squared function. When x gets really big, all the lower powers become insignificant. And if it's a degree 3 divided by a degree 2, it means it's a degree 1. Now, it might be a negative multiple of x to the 1 or a positive multiple of x to the 1. Okay? It might have a y-intercept other than 0. So it's not actually the y equals x function, but it's going to be of degree 1. So there's going to be some straight line here that this thing is asymptotic to. You call that a slant asymptote. Okay? Find the slant asymptote. Do the long division. Now, first, you better expand the numerator. As needed, because you have to have a polynomial in its general form before you can do the long division. And notice our numerator is x minus 2 times x squared plus 3x plus 7. That's not something you want as your dividend, okay? So numerator is x minus 2 times x squared plus 3x plus 7 equals, and you use the distributive law, x times all this minus 2 times all this. And I'll do it in my head. And hopefully I'll get it right. You're gonna have an x times x squared, which gives you x cubed. You have an x times 3x, which gives you 3x squared, and a negative 2 times x squared, which is a negative 2x squared. 3x squared minus 2x squared is x squared. And then x times 7, well, that's 7x. And negative 2 times 3x is negative 6x. Well, this comes out pretty easy. That's plus x. And then it's minus 14. all right? So the coefficients all turn out to be 1, and the constant term just minus 14. If I did that right, I did it in my head, doesn't work out, you can work it out, okay? So we do the long division. That's pretty easy now. The denominator is x squared plus 5x plus 6. It's going to get a little bit long. I'm going to cheat and do that on this board where I have a little more flexibility. Okay, we have x squared plus 5x plus 6 divided into x cubed plus x squared plus x minus 14. Well, we're going to have an x up here because that's the only way this times this is going to give us an x cubed. We have x cubed, then it's plus 5x squared plus 6x. So we've got this much of our dividend if we just have an x here. Well, let's subtract that off and see how much more we need. Well, this is going to give us 6x squared minus 5x. We'll put the minus 14 there. So we're going to need a 6 here in order to take care of that 6x squared. So we're going to have 6x squared plus 30x plus 36. And of course, we got to subtract each one of these. Uh-oh, yeah, that's where they did it right. So we have negative 35x minus 50. This is a remainder. So we write that as plus negative 35x minus 50 over x squared plus 5x plus 6. That'll be a little hard to read, but so the quotient and the quotient is still r of x, because r of x is just divided by this, right? When we started out, we had this numerator and this denominator. Now the numerator was expressed as x minus 2 times x squared plus 3x plus 7, but we saw that that was the same as this, right? So all we're doing is we're dividing the numerator by the denominator. This is still what r of x is. And it's x plus 6. And I'll since these both negative, I'll do minus 35x plus 50 over x squared plus 5x plus 6. What's this mean? Because that goes to infinity, plus or minus infinity. This goes to 0 because you only have an x term in the numerator, you have an x squared term in the denominator. And if x is like a billion, x squared is going to be 1 followed by 18 zeros. X is only going to be 1 followed by 9 zeros. Okay, this number is going to be way bigger than this number, and the 5x and the 6 don't really have much effect here. Okay, you're going to have a huge number here, and this is going to be a pretty big number too. But this number is way, way bigger than this one. When you divide a number by a number that's way, way bigger, you're going to get something close to 0. Okay. Example. If you've got 6 pizzas and you divide that among 12 people, everybody gets half a pizza, right? That's a pretty good chunk of pizza. Now, if you share it among 120 people, everybody gets just a 20th of a pizza. Okay? That still tasty. Okay, divided among 1,000 people, everybody gets about a teaspoonful. Okay? And the more people you divide it among, the less you get. So the bigger this number gets compared to this number, closer you get to zero. All right? Because again, when you divide a bigger number into a smaller number, you get a smaller number. And the bigger, well, we go on, but you get the idea, hopefully. And hopefully Open Math has already instilled that idea into you, hopefully not by telling you to punch buttons on a calculator. You need to understand instead of punching buttons. I mean, punching buttons is great. If you got to actually calculate that, sure, punch buttons. But if you want to understand what happens as x goes to plus or minus infinity, you better think about what it means to divide a number by a much bigger number. You better have an intuition about that. Okay. This is going to be important when you get to calculus, assuming you're going to take a calculus course, okay? This sort of thing, so I kind of stress it. This being a pre-calculus course. All right. In any case, back to where we are. You know, we've found the zeros of the numerator, found the zeros of the denominator. We've marked the corresponding points and asymptotes. We're looking at the long run behavior. We learned that the long run is going to be like the first power of x, okay? And as x gets big, this thing gradually approaches disappearance. And we're left with x plus 6, okay? So I'll say that power of x approximately x plus 6. Well, now I've got a little bit of a problem with my graph over here. Let's work in the long run behavior. I'm going to change one thing. So there's our long run. Okay. And I'll have this long run. I progressed over here, do all the calculations. But now I see, if I got this on my paper in some semi-coherent form, even if it's scattered, but if I've got all this together in one area, all this together in another area, and all this together then I see, and of course I got this, I've got all four of these things. Check that off of my checklist, my to-do list. Right? Okay. Now, problem is graphing y equals x plus 6. This is a little more than -2 units here. So 6 units would be about 3 times that much. So my y-intercept of the x plus 6 graph would be all the way up here, which would make it really hard to get my long run on this side into the graph without going outside the bounds that I've sort of set for the graph. So what I'm going to do, I'm going to get rid of this line. And I'm just going to rescale my y-axis by putting y equals -7/3 about here. And here's my y-intercept. And I'll try to connect those lines back together. Okay. And that allows me to put my x-intercept about 1, 2, 3 times up here. So this might be 6. And that's not my x-intercept, it's my y-intercept. See why I want you to keep writing these things down? Y equals, y equals, y equals. It's so I won't get confused, okay? Now, really, so you won't get confused, because if I have a tendency to do it backwards, most of you are going to have a pretty strong tendency to do it backwards. You have to stop and think. Okay. Anyhow, there's y equals 6. Now, that's not actually an intercept, so I really don't want to do this. But now I can draw my y equals 6x, x plus 6 graph. Another thing is that 2 units of y is about this big, whereas 2 units of x is about this big. Okay? That's going to distort the look of my graph. The y-intercept of this graph would be at x equals -6. I'm sorry. It's at x equals 6. So the x-intercept would be at x equals -6. See what I mean about confusion? Write things out so you can always check your confusion. Okay, so x equals -6. Well, that's matter, but that's like over here. So we're going to go through this point and this point. That one came out pretty well. Actually, pretty well hit the intercept. I was a little low over here. Okay, anyhow. You see why I never brag, because I always screw up. Okay, we got y equals x plus 6. And I don't know where to label it, but right now just accept that that's y equals x plus 6 until we get the rest of the graph drawn. Okay, so the graph has to be asymptotic to this line. So it has to come up from here. But it can't go through the x-axis because there are no zeros. The only zero is here. So it's going to have to turn around. Comes up from here, it's going to turn around. And fortunately, we've got a vertical asymptote there to turn around and approach. So what's going to happen with my graph? I'll start way down here. And it's going to come up here, but it can't go through the x-axis, so it's going to turn around and approach this vertical asymptote here. Okay. Now, this asymptote came from an x plus 3 in the denominator, right? 1 over x plus 3 is just a horizontal shift of -3 units for the reciprocal function. So this is just the reciprocal function shifted over 3 units, but vertically stretched by all that other stuff in the function. That means that on this side, it's going to come down from here. Okay, I don't want to come down too far because you know what's going to happen. It can't go through the x-axis. And then it's got to approach this. The only way to do that is to come down here and make a U-turn. And it looks a whole lot like a U, although it will be lopsided on one side or another, depending on how those other numbers work out. And you don't have to worry about that. Once you learn calculus, you'll have a very easy way of determining where the low point of this thing is. And then you'd be able to do a much more accurate graph if that was called for. Okay. I wish this thing would continue to tell me it's recording, because I can go on for hours with the thing off the recording and I look at it, it tells me nothing. Very irritating. Okay. Anyhow, there it is. Now, this is another function that comes from the x plus 2 in the denominator. 1 over x plus 2 is just 1 over x shifted over 2 units to the left. Now, it's got an asymptote up here, which means that all the other stuff in the function must be negative. okay? Near x minus 2, the rest of the function is going to be negative. So you're going to have like this and this here, okay? Because it's just 1 over x. If it's 1 over x plus 2 squared, it would approach the asymptote either on both sides, either positive or negative. Since it's a 1 over x function, it approaches the asymptote on at opposite ends of the x equals negative 2 graph. Not particularly good way to say that. So it just means we got to come up from here. Now, what else do we have to do? Well, we've got to go through this point and this point, and we've got to be asymptotic to this line. It's not too hard to do. We just come on up here and here. And maybe it wiggles a little bit, so it can be asymptotic, but probably not. But again, calculus will tell you if that has a wiggle. You know, it tries to wiggle a little bit there. So I kind of question whether that's accurate. On the scale of the graph, I think maybe it could be, but I kind of doubt it. All right. There's a construction. Again, 4 steps. Then put it together in the graph. Okay? You can do that if you have time, or if you understand it at this point. I wouldn't spend a lot of extra time on it until you're really sure that you know everything you need to know to do well on the test. Okay? And then if you happen to remember this and you see a problem with rational roots, it'd probably be simpler than this one. And for a rational function, you know, it's your option to give it a try. Okay, you got y equals 2 to the x. Every time x changes by 1, y doubles. Okay. Got y equals b to the x. And have a graph that looks like this. The graph is still going to look a whole lot like the x squared graph. Okay. Let's say here's y equals 1. Then here could be y equals 2. And we see that the y value doubles between here and here, right? And then if we go up to y equals 4, it doubles again. If we come back this way, well, coming back this way, it cuts in half, then in half again, which means if we start here, it doubles, and it doubles. Okay? We just don't know what number doubles this thing. So here's a graph. Now all these intervals should be the same length, but this is doubling time, and it's always the same. That makes sense? That means you can construct the 2 to the x graph without using any numbers. And if you can figure out what the doubling time is, then you know how to label your x-axis. Okay? Find the doubling time. It's T dub, D-O-U-B. There's a simple equation you can solve. B to the x plus T dub equals 2B to the x. Now, I'm not actually going to have you use that equation right away, but I want you to get that in mind. Does that make sense? If x increases by T dub, then it's got to double. If T dub is the doubling time. Okay? And it's pretty easy to solve that equation. I don't want to get into the algebra of it right now, but kind of get that in your head. That's a good thing. That's in many cases the most important aspect of an exponential function. In the characteristic aspect of the exponential function, every exponential function is going to have a consistent doubling time. Well, okay, great. Now let's say I'm not Elon Musk, but let's say I give everybody $1,000 instead of $1 million. Okay. Yeah, I'm not going to do that. But if I give everybody $1,000, you have them and you invest it in an account that pays 4% annually. Year 0, which is when you get it, you have $1,000, right? Now, how much do you have after a year? Well, 4% of 1,000 is 40. So after a year, you have $1,040. Now, if you don't go out celebrating, buying a fancy car for that $40 or a big expensive meal or whatever, well, you can't do all that much with $40. You might as well leave it there. Okay. Now, the other thing I'll say is compounded annually. That means in year 2, you can add 4% to the 1,040. Okay. And that's going to give you $40 plus $1.60, $1,081.60. Well, that extra $1.60 that you would have if you only had $1,040, which would base your interest on $1,000 rather than $1,040, doesn't seem like a big deal. Okay, but it grows, and it's important for your financial future to understand how these things grow. Okay. Well, after 3 years, well, okay. Now, If you add 4%, that's the same as multiplying by 1.04. So if I repeat my table, I hope you can multiply 1,000 by 1.04 in your head. You just gotta move your decimal over here 3 places, and it's going to give you 1,040. Okay? In year 2, you take what you have here and multiply it again by 1.04, right? In year 3, you take what you got here and multiply by 1.04. You see a pattern. What do you think you would have after 10 years? You discuss it for a minute. Okay, I should have kept the recording on there because we didn't really need to discuss it. You see that after 3 years, I've multiplied by 1.04. How many times I asked people to show me with their fingers? Everybody held up 3 fingers, right? Because we multiplied by 1.04 3 times. After 10 years, how many? Well, everybody held up all the fingers in both of their hands. And, fortunately, I haven't checked to make sure that everybody does have 5 fingers in each hand, but I think we can kind of expect that everybody seems to have a full set of digits and no extras. Okay? So everybody's gonna hold up 10 fingers. Okay, well, my point now is year amount 0, 1,000, 1,000 times 1.04. We already see the pattern. So that in year 10, I don't want to write out all those 1.04s. Somebody tell me how I could write that out a little more efficiently. Okay, well, I could write out 10 1.04s here, right? But it's really easier if I come up here. Why don't I just call this 1,000 times 1.04 squared? Because 1.04 times 1.04 is 1.04 squared. So when I come down to the 10th year, I'll have to have 10 of these out there, but that's just 1.04 to the 10th. Then we go out to any year. You take your calculator, because you wouldn't need your calculator to raise 1.04 to the 10th power. That's a perfectly appropriate use of your calculator. Okay, you approximate it pretty well using the binomial theorem, but I don't think anybody ever even teaches the darn thing anymore, which is too bad, because it's really important. But okay, 1.04 to the 10th. If you wanted to know how much you had after 100 years, of course, I don't reckon you're necessarily planning to live that long. Say after 50 years. Okay? Y'all ought to be good for another 50 years. Okay. You do 1.04 to the 50th. You got your calculator. I'm not going to take the time to do it, but you can punch it in. All right. So I can say if the year is X instead of 10, well, we did have 1.04 X times, right? What's the doubling time? Then give us something. I do want to write it out. You have this. Make sense? Well, let me write it bigger. There it is. Now, what's 1.04 to the x plus t dot? First of all, I can divide both sides by 1,000, right? I get 1.04 to the x plus t dot equals 1.04 equals up equals 2 times 1,000. Okay, I didn't put my factor 2 in there like I did here. Okay. Now I can write 1.04 to the x plus t dub as 1.04 to the x times 1.04 to the t dub. Because of the rules of exponents, multiply the same base to 2 different powers, I add the powers. If you don't know the laws of exponents backwards and forwards, you really need to review them. You know, sometime before your first assignment or your second assignment, exponential functions. I've got a 1.04 to the x here and a 1.04 to the x here. They're factors, right? They're multipliers of the equation. I get 1.04 the t dub equals 2. So all you gotta do is solve that equation. Problem is, you don't know how to solve that equation. Unless you remember something from a pretty good Algebra 2 course that got into logarithms, okay? And most people, even if they touched on it, don't retain it to this point, and that's understandable, okay? I don't think that's the efficiency of the system. All for t dub. T dub is somewhere around 18. Means in 18 years, your investment will be worth $2,000. 18 more years, it'll be worth double that, 4,000. And 18 more years after that, 54 years from then, when you're around my age, be worth $8,000, right? So that's kind of the power of compound interest. You know, you also have inflation, which works the other way, and it kind of compounds too. But historically, you know, since I was your age, the value buying power of the money is going up faster than inflation has impeded it, okay? No guarantee that'll always be the case, but it's historically the average. Okay, now that's a little bit about exponential functions, the problems you're going to have, and I'll talk about them a little bit Thursday. There will be some problems due next week on exponential functions, because we have to keep moving, okay? You don't want everything to pile up on you at final time. Okay, a few words about the exam. Don't know if anybody is contemplating dropping this course. Everybody's showing up, everybody's doing the work. And hopefully nobody will want to do that. And incidentally, I started emailing the feedback on your test over the weekend, and the email stopped working. So I intended to get that to you a lot quicker, but I'll do my best to get it to you this afternoon. Okay. So some of you got emails. How many did get emails? Okay, and the rest of you, I'm sorry, the email system doesn't want you to know, but I'm going to make sure you do anyway. Okay, so you're going to want to take this by next Tuesday, week from today. Okay, otherwise you won't have feedback on the test when the drop date comes. Another thing, if from the midterm test and the homework and attendance and everything, anybody does not appear to be passing, I'm going to drop you. Because if I drop you, you can then ask me to reinstate you and put you back into the course. If you drop yourself, you're gone. Nothing I can do. Okay? So I will drop you. It doesn't mean I want you gone. It just means I don't want you to fail. I want you to make sure that you're on track to pass the course. Does that make sense? Okay? It's just gaming the system, if you will, for anybody that's been attending and getting the homework done. That's going to be a possibility. I don't think it's necessary for most of you, but it depends on your goals for the course and so forth. I mean, if you feel like you got to make an A or a B and you're making a C or a D, you still might decide you would rather have a W than a C or a D or transcript. We can talk about it at that point. Okay, so feel free to come and talk to me, email me, get my thinking, tell me your thinking, figure out what to do if that occurs. Okay. We're a little bunched up here due to various factors, including the hurricane and a couple of other unexpected things. But I think most people are going to be in fairly good shape. Remember that you're going to need to be able to do everything that was on the major quiz you had before. All that could appear on the test, and stuff that didn't happen to appear could appear. Okay, plus the stuff on power functions, quadratic functions, polynomials. Fair enough? Okay, I think it's manageable. I think you do well.